Hey everyone, so I'm John. Thanks for coming out. A little steamy in here, huh? How's everyone doing? Everyone all right? Cool. Okay, so I work in New York City on the startup team. So I work with startups of all ages and sizes. And a large focus of what I do day to day is help startups use AWS more efficiently and save money. It's something we proselytize to customers of all sizes, even the large enterprise customers. But for small customers, it's even more pivotal, right? Because every dollar is an extension of the runway that startup could use to get that next round of funding or find their product market fit or whatever it is. How many folks here today are using AWS? Okay, so you're all actively building on AWS. How many of you suspect that you might be able to, suspect you might be overspending? Okay, yeah, cool. So all of you have access to an account manager and someone like me, a solutions architect, and you can get in touch with them and get him or her to look at your account and help you optimize your spend, right? We're eager to do it. It's something, it's a very fun game. So if you take nothing out of this next 30 minutes or so of us talking about cost optimization, take that as homework. Find your account manager, call him or her, say you want to do a cost optimization session with an SA. Okay. So what to expect? We're going to go through, just on a high level, some benefits of the cloud, vis-a-vis cost. We're going to talk about right-sizing your environment for your workload. We're going to talk specifically about development environments, which is a great first target for cost optimization activities. We're going to talk about density, how to think about using containerization to reduce compute costs. And we're going to talk about serverless in terms of how it can affect your overall spend. So cost benefits of the cloud, we'll just go through this very quickly. The benefits of AWS allow you to move from a forecast model to a consumption model, right? So instead of getting that PO and ordering a bunch of systems and rack and stacking them, you can instead just pay for what you're actually using and be billed on a utility model. Super important, this is the big leap. This is what enables startups on the cloud. The fact that you no longer have to guess what you need, you can measure it, figure out what you need, and provision just that capacity. You benefit from the economies of scale, so AWS has millions of active customers, and you benefit from all of that kind of innovation and all of the price pressure that those millions of customers put on. I mean, Amazon's a peculiar company when it comes to pricing in general. Our teams are internally constantly pushed to take cost out of their own cost structure so we could take those savings and pass them on to customers in the form of lower prices. I think the number is we've done over 60 price drops as of now in AWS's history. So we're always trying to reduce prices for our customers. And talks like this, we want to help our customers take advantage of those lower prices. You're no longer spending money on data center operations, so instead of sitting there wiring up patch cables, crimping cables, you're spending money on developing your software for your business, for your customers. You could transparently attribute your expenditure. So you could know through the AWS platform if that dollar is being spent towards your development environment or your production environment or business groups A's project or business group B. The tools are there for you to take advantage of to really granularly track where your money is going and why. Continuously reevaluate design choices. So again, back to the PO, you sign that PO, that money's gone, and you're on a 3-year depreciation cycle. With AWS, you could continually look at what you've done, what your infrastructure is, resize it, right-size it, measure, refine, iterate, et cetera. And then finally, managed services. So if you look at AWS in 2006 through and a couple years following that, the primitives were primitive, right? There were storage, S3, compute, EC2, just basically giving you object storage and compute. If you look at the last couple of years, 2014, Lambda, a lot of the services that we're shipping are further up the stack, and they're managed services that reduce the concern space of what you actually have to manage. We'll talk more about that. It's important to think about sort of the amount of effort and time and mind share of your team that goes to scaling your business, right? And how much of that is going toward building features and products and business value for your customers, and how much of it is going towards infrastructure, or how much is it going towards this undifferentiated heavy lifting of managing a bunch of Unix servers or racking and stacking a bunch of networking equipment. And maybe in your early days with 1 million users, it's negligible. You have a couple of engineers, and they handle that. But as you grow, those concerns are only going to keep growing, right? As your data increases, as your compute needs evolve, you're going to need to continue to invest in staff to handle that. And it just kind of sharply increases. If you can outsource all of that work, just offshore, like ship it off to a company like AWS, like take that every time, right? Like take that deal every time. Instead of worrying about security patches on your servers, if you could have AWS manage that for you, that's a win. Because time is a zero-sum game. It's the most precious commodity you have as a startup. And the time is the fire in which we burn, as they say. So just talking about where cost savings come from, generally what we find with customers is that there's this kind of 80-20 split, like the Pareto principle. So generally 80% of the cost bloat, if we look at a customer's invoice, will come from 20% of the causes. And that's generally things like compute, EC2, and storage on S3. And because of this, and because the AWS platform is now over 10 years old, and no two workloads are the same, they're all very different, AWS has lots of different mechanics in each of their services to help you acquire these two services at the exact right amount of your workload. So for example, on EC2, there are multiple pricing structures, different ways to acquire compute capacity. On S3, there are different ways to store data with different pricing structures. We'll talk a little bit more about that. But generally, there's this split where 20% of the problem is 20% of the causes usually result in 80% of the problem. So by being smart about storage and compute, you can have a major impact on your spend. If you just look at EC2 and start there, that's generally the 80% of cost reductions. So just a couple of quick things off the top of off the top here on EC2, ways you can reduce your spend. So if you look at EC2, there are three major ways to acquire compute capacity in EC2. There's on demand, right? You pay AWS by the second if you're using most distributions of Linux, or by the hour with some commercial distributions or Windows. And what you're only charged for what you use. If you use it for 3 hours, 15 minutes, you get charged for those 3 hours, 15 minutes. The other two ways are you can reserve capacity. So you could say, I have this workload. This system's going to be up 24 hours a day, 7 days a week. It's never going to go down. I want to reserve that capacity. And AWS will give you a discount for reserving that capacity. And there's quite a lot of different mechanics within reserved instances. There are convertible instances. There's 1-year terms, 3-year terms. So you could size your reservation to your actual needs. So that's the second way. First way is on demand, pay by the hour, pay by the second. Reserved instances, I know I'm going to need this for a year. I'm going to pay you less money for the year. And the third is the spot market. Well, the spot market allows you to acquire unused EC2 compute capacity at a steep discount. It could be like 90% in most cases. So this is great for things like big data processing, or maybe you're building an AI model. Maybe you're running some sort of job that's interruptible in some way. So spot instances, the trade-off for that 90% savings is they're interruptible. So within 2 minutes, you can get a warning that says, hey, actually you were outbid for this kind of instance. The marketplace price changed. You're going to lose that instance. The instance gets terminated on you. But if you're running some sort of workload where you have interruptible work, that doesn't really matter. It's better to bank that 90%, put it back in your pocket. In addition to that, there are other, so reserved instances being the last one here. You could reserve capacity. Always something we do with companies who have that database server that's just never going away. Pay less for it. You're going to run it 24/7. Work with your account manager to figure out the right type of reserved instance, but make sure you're paying the least amount of money possible for it. And then in the middle, there are mechanisms to reduce your spend that are less about the way you purchase and more about how you operate those instances. So for example, with autoscaling, if you have an autoscaling group, you can have your web farm or your server farm grow and shrink based upon your actual demand, right? So think about a company like Pinterest. So Pinterest is a very popular website. They have a pretty predictable traffic cycle if you look at it. If you pull out and look at a week view, that's kind of like during the day, during business hours, there's a lot of traffic. During the night, it dips down. There's a trough, then back up. Without autoscaling, they'd have to run some percentage above that peak, right? They would have to say, okay, we're going to acquire enough instances to handle our peak load plus 15% or whatever it is. With autoscaling, they can have EC2 adjust depending upon what their actual demand is. So based upon CPU utilization or based upon even like user-facing latency. If latency crawls above a certain number, spin up more servers, spread that load out. This ultimately reduces your cost, right? It matches the amount of money that you're spending to your actual customer demand. And that's one of the overarching themes here. You want to match the amount of money you're spending to your consumer demand exactly. EC2 Scheduler is a project that we built internally similar to autoscaling. It helps you stop and start instances on a schedule. So if you have, and we're going to talk a little bit more about this, but if you have a development environment, your developers probably aren't working at midnight, I hope, you can turn off those instances at 8 p.m. or 6 p.m. or whatever it is and turn them back on at 8 a.m. the next day and bank that 12 hours of runtime. Instead of paying that, the amount of money you'd be paying to keep that server running all the time and doing nothing, you can use mechanisms like this to ensure that you're not wasting that money, pouring money down the drain. It's kind of like when I was a kid and I'd stay home from school, I remember there were two game shows on back to back. One was called Supermarket Sweep, which was like this ridiculous game show where you had like a shopping cart and you had to like spend the most money possible. And right after that was The Price is Right. Right, so like we want our customers not to do the supermarket sweep thing where they're just like blindly grabbing things off the shelf. We want to make sure that customers are like doing more of a Price is Right, like figuring out exactly what they need to spend and not spending a nickel above that. Yes, please.
We have free accounts.
Like the free tier.
Yes, and then we're trying to develop some API gateway API.
Okay.
And then working on the Lambda function, integrating all these get post methods and resources.
Mm-hmm.
And at the end, we see some error. And we came over here, they couldn't find the error. And I had to work at least 1 week. At the same time, I would get the charge for EC2. Which method I can use that, stop running my EC2 and then get back?
Yeah, so the EC2 scheduler is a great option there, and we'll talk more about that after. Maybe you and I should just talk after and talk about your specific problem. Okay, cool. So getting back to cost awareness and education, one thing that I've found working on teams building on top of the cloud is that it's kind of like the costs of your infrastructure grow day by day, right? It's not like a thing where you're like, okay, this is going to cost us $3,000 a month and it kind of stays that way in perpetuity. What generally happens is you start out with an infrastructure and you have a monthly run rate, and then month after month it slowly creeps up, right? It's kind of like weight gain. If you're not stepping on the scale every day, like you may look in the mirror one day and be like, oh, I guess I need to change my diet or something, right? Like if you're not constantly in an ambient way aware of your spend, it could get away from you fast. So one trick that I found is that when I've inherited projects or inherited teams, first thing I do is I set up a nightly alert every day to hit Slack or HipChat or Campfire or whatever I'm using, just to take the current month-to-date spend and put it in the channel, put it in the dev channel, right? So that everyone knows that, hey, here's what we're spending today. Maybe we're on track, maybe we're off track, but everyone's aware of it in an ambient way. If you have like a dashboard of performance metrics or business metrics or maybe even some logging utilities like just on the wall, it's great to put this number on there, right? And AWS has a bunch of APIs to help you get at that number. Just make sure people are aware of the cost, right? It's like the first thing you can do to kind of get your team to think about things in a cost-conscious, more frugal way. And then on that, right, we talk about attributing expenditure. So the first thing you do when you sort of deploy to AWS is you spin up a bunch of stuff. Hopefully you're doing that through some sort of infrastructure as code tool like AWS CloudFormation or HashiCorp's Terraform. But you're probably not thinking like we need to attribute which servers are for which purpose, right? And you only do that sort of post facto when there's some questions about the bill and you need to figure out where spend is happening. With AWS resource tagging, you can tag your resources and say, well, this DynamoDB table is for this project, or this EC2 instance is servicing this team, this internal business function. And you could run reports, either through the billing console, or frankly, you could just download the raw data and put it in Excel, and then understand exactly where your spend is going. And it's just really good practice to start doing this from day one. So I mentioned before, Amazon.com, every team is sort of incentivized to reduce their cost structure, right? It's something that we're pretty religious about. It's also something engineers love doing, right? If you give, it's a great game because it's very easy to keep score. If you have 3 projects, you can measure how much those 3 projects are costing you on a monthly run rate basis, and ensure that your engineers have the data they need to be able to optimize further. So thinking about your resources and tagging them from day one is pretty important and pretty powerful. And it's a fun competition. Yes?
How do you set up tagging?
It's different for every service. So for EC2, for example, there's an API call where you can tag running instances, or you can add tags to it when you create the instance. So for example, there's this deck will be online, and there's a link, I believe, to the documentation on resource tagging. It's worth spending some time in there, for sure. And then, finally, another thing is just understanding how much of your system is idle, right? Like, every system that I've ever operated has, like, its own sort of like health signature, right? They have their own characteristics around load. They have their own characteristics around latency. They have their own, like, signature around, like, if you look at the graphs of, like, things like CPU and memory and latency, and they generally tend to have patterns. Understanding how much of your system is idle, how much spare capacity you have, that's just opportunity, right? That idle capacity, if you can kill that idle capacity and bank it, your costs go down, and you're spending less money on basically you're paying Amazon less, which is good for you and frankly better for Amazon in the long run. It's like using all of the Buffalo. If you have an entire EC2 server and it's 5% utilized, maybe it runs a cron job every 12 hours, there's probably a better way to do that. We'll talk a little bit more about that in a minute. On the visibility perspective and on the awareness perspective, it's really good to sort of like break down that number too. So there's a monthly run rate number which tells you, okay, we're spending this much. But here's what really matters, right? Like, how much does it cost to you per user to deliver your service? If you have, in this case, we have 9,800 daily active users, and our spend is 4,200. Well, that nets out to 44 cents per, right? So on average, for this month in particular, it's costing me 44 cents per user to operate my business. And is my business netting more than 44 cents from that user? Good to know this number. Also good to know how it's changing over time. So here the number of users is growing more sharply than cost, which is great and exactly what we want to see. And you want to get to the point where your cost kind of flattens out and you take advantage of your own economies of scale as your user base grows. This is not realistic. There's no way anyone's paying $4,200 for less than 10,000 users. But anyway, the point is the same. It's good to know kind of like what this per number is to help you plan and project and forecast. Let's talk a little bit about right sizing. So getting the right resource for your workload is super important. Part of that is about understanding your workload, understanding where the constraints are. Are you running something that requires a lot of memory, right, but maybe not a lot of CPU? Or are you running something that's extremely CPU intensive, but doesn't require any memory or doesn't have much I/O to speak of, doesn't need any disk? Understanding kind of where you are and which one of these cylinders is important to your workload will help you pick the right set of resources to power that workload. So for example, with EC2, there's instance types from the T2 Nano, I think it is. It's basically 1 vCPU and half a gig of RAM, I believe, and it costs less than a penny an hour. Right, and it scales all the way up to the X1 32 large or whatever it is that has terabytes of memory, right? So there's a huge spread of the types of instances that you could be running, and there's specialization within that spread for every kind of workload that in between. So if you have a CPU intensive workload, perhaps you need a CPU intensive instance, right? A CPU instance like a C4. maybe that's more appropriate for your spend type. So adding more instances without really understanding, just saying, oh, wow, we heard from customer support, customers are saying the site is slow, what do we do? Saying like, okay, we'll just add 4 more instances. That's like that's like an alarm bell, right? That shows that you're not, you need to spend a little bit more time understanding your workload so you can just not turn one knob, but like figure out the right knobs to turn. AWS, 90+ services, there's a lot of knobs, and figuring out how to turn the right ones is a function of understanding your workload's needs and how to best service that within the platform. Different applications require different resources, obviously. There are some, depending on the tool sets you use, depending on what your application is actually doing, it's going to change the size of these cylinders and what you actually need to provision. And then optimization of your workload. So understanding these numbers helps you eliminate idle time, which is great. It helps you scale much more deliberately and specifically, which is also great. But it's also going to tell you what might not be working about your application. It might show you that, hey, when someone hits our user's endpoint, that takes 800 milliseconds. Why is it taking 800 milliseconds to look up a user? Because throughput is a function of how much you can get done within a given period of time, and latency is the amount of time the requests take, right? So if 800 milliseconds, a user is waiting 800 milliseconds for that simple response, it's going to affect your throughput and it's going to affect your user's experience. So there's the other benefit of understanding your workload. It's not just about like tuning it for the cloud. It's also about understanding where your opportunities are to optimize to give your customers a better experience. Load testing is part of this. It's not often, it's not something startups do early on, right? Load testing is kind of on the low list of priorities. Staying alive and making sure everyone gets paid is higher up on the list. Load testing is usually somewhere in the couple hundred range. But you can reach a point where it makes sense to start understanding the boundaries of what your application can do. And there's a ton of load testing tools, both open source tools, there's a bunch here, but also in our marketplace, in the APN, in the AWS marketplace, you'll find a bunch of commercial load testing tools that you can use out of the box to stress test your application to understand both its throughput and latency dynamics. You could even, a lot of customers who find load testing to be imperative, what they'll end up doing is not just load testing as a kind of a post facto exercise, but load testing throughout their development process. So you can actually, and this is common, you can integrate load testing tools into a continuous delivery pipeline, such that if a regression occurs and that user's endpoint, maybe it was 30 milliseconds, right, before somebody added a feature to it and blew it, and now it's 800 milliseconds. Instead of catching that in production, if you do load testing as part of your delivery process, whether it's manual or automated through a CI/CD pipeline, you can catch that before you ever ship it to users and nip it in the bud. Just more about latency and throughput. So this is subtle. It's just important to think about these two numbers and what they mean, because they're related but different. They're orthogonal concepts. So latency, it's going to measure the end-to-end processing time, right? If I have a function and all it does is sleep 1, right? The latency of that function will always be 1-ish, right? A little over 1, but 1-ish. Always, right? So there will be a second of latency to get the result of that operation. Throughput is different. Throughput means the amount of requests that can be processed through a server within a given period of time. So let's say it's a second. If I have 4 web workers and I'm in a single-threaded environment, and it can only handle 1 request at a time, then my throughput on that sleep 1 function is going to be 4. So I'm going to be able to handle 4 requests in a given second, and each request is going to take a second, no matter what I do, right? So there are ways to change these independently, right? Throughput, if you add 8 workers, now your throughput is 8. If you have 12 workers, now your throughput is 12. Latency, if I said sleep 0.5 instead of sleep 1, well, now my 4 web workers can do 8 in a given second, right? So important to understand, there's a lot of nuance here between these two numbers, but important to understand both of these numbers vis-a-vis your application. What is the latency of the different endpoints of my application, and what is the throughput? How much traffic can I actually handle? having good measurements helps you kind of figure this out, right? So this graph is great. This graph is an opportunity. So here, this is CPU of an instance. And what we see here is that for, this is what, an hour? Nope, half hour. So for half of this half hour, this server was basically completely idle. And then for 15 minutes of it, it was at 100%, right? So for 15 of those minutes, we were spending money on this server that didn't have to be running, right? So this is like a hidden jewel of an instance in your account that you can take action on and save money. And you know, if you've not spent a lot of time in CloudWatch metrics, I encourage you just to like take a couple hours and just look at all your graphs, build some dashboards, right? Build some dashboards for your application, and get to understand the heartbeat and signature of your system, and find opportunities like this to save money. Like maybe this is a server that runs a job at 1820, 620 every night. Well, maybe this doesn't need to be a server running. Maybe this could be a Lambda function or a step function that is automated through CloudWatch events that just runs and does its job, and you only pay for the amount of processing time you're actually using instead of paying for this extra 15 minutes. On this note, so there's this kind of snarky corollary to Moore's law, Gates' law or Worth's law. The idea is that like software is getting crappier and slower faster than hardware is getting faster, right? So the whole Moore's law thing of every 18 months of doubling of speed, developers like us are blowing it and making things worse faster than the hardware can compensate. And we're doing that for good reason. We have the best of intentions. We are trying to ship newer, cooler features to our customers. But this is pretty common, right? You'll have an endpoint, like a friend's endpoint here. V1 will be super snappy, 32 milliseconds. By the time our product folks and our dev team is done with it, we've added 16 milliseconds to it on latency, right? So understanding, tracking and understanding and measuring this kind of latency on an endpoint by endpoint basis is also really important. Again, it's just part of your system's behavior. It's part of its health signature. Typically stuff like this gets caught in code review or potentially. The gold standard is to catch this jump, and 16 milliseconds, this isn't the end of the world. But what if this was 800 milliseconds, right? Nipping that during the development cycle rather than having your customers discovering it is the goal. Right? So figuring out a way to measure this proactively. What's in production today? How is it operating? Will I get alerted if my endpoint becomes super latent? And then catching it in development so that your customers don't actually feel that pain if it's actually changed, if the latency increase is a result of some change you made in development. Another tool, so there's a bunch of interesting tools that I think our support team builds. So one is called EC2 right sizing. It's essentially a group of Python scripts that you could deploy through a CloudFormation template onto an instance. And it will look at all of your instances and it will tell you, it'll give you suggestions on how to optimize your spend. Say like, this instance has been idle 95% of the time. Can you use something like the EC2 scheduler to start and stop it? Or can you employ autoscaling? Or maybe you're just not using that instance anymore. Something we commonly find, we'll sit down with a customer and the customer, he or she will say, I'm spending too much money. We'll look at their account and we'll ask, where are you deployed? They'll say Northern Virginia. And then we'll find like, oh, you have several $100s of instances running in Oregon. Did you know? No, I didn't know, right? So if you're not, with the rate of new growth, new hires that you're making as a startup, with the fact that the first engineer, he or she's going to grow so many responsibilities that they may not recall every micro decision they made in the first year of the company's life, using tools like this to sort of verify what's been done in the past is super important to be able to identify opportunities to reduce your spend. On that note, there's a service called Trusted Advisors. Anyone using Trusted Advisor? Anyone at all? Okay, awesome, cool. So there's probably, there's thousands of folks at AWS with my job, right? And our job is to work with customers to help them not only on cost optimization, but to ensure that they're using the platform as securely as possible with the most reliability and fault tolerance and for the best performance, right? And sometimes these are tugs on each other. We've codified a lot of the suggestions we make over and over again to customers and what we've learned, frankly, from our customers educating us on what they need into Trusted Advisor. you can go into Trusted Advisor and get cost optimization recommendations. So without doing any work on your own, you click on Trusted Advisor, you click on cost, the cost pillar, and it'll show you some opportunities. Like, you're running a load balancer, but that load balancer doesn't have any instances on it. You're just paying $20 a month for no reason. Click here to destroy it. So really, really good. Like, we always start here with customers. Like, let's go into Trusted Advisor. Let's look at what the tool is suggesting to you, and let's treat that as a starting point. Usually there's some really good low-hanging fruit in there. So I'd encourage you all to check that out.
That's a free tool to run?
So with business support, it's all free. So if you have a business support account, you get it. Without business support, there's you get access to some of the data, but not all of the data. So let's talk about density a little bit. So this is going back to compute, right? So this is a pretty typical kind of like application deployment. So here we have 5 EC2 instances, right? And here's sort of like, this is AWS's problem, right? This is the water line of responsibility. And this is your application, your dependencies, your binaries. Notice something here. So we have 5 instances running. This is CPU utilization. Those numbers are kind of all over the map, right? So one system, we have on average a 9% utilization. One, we have a 57% utilization. So, perhaps this is running a very lightweight application that doesn't require much CPU. Perhaps this is running a little bit more of a dog, like an application that requires a little bit more CPU. But we're spending the same amount of money, right? So there's resources here. Let's pretend for assumption that these are all the same kind of instance. But we're not utilizing them all to their full potential. We're not using all of the buffalo, right? Like Native Americans, we're only using 9% of this particular buffalo. So how do we increase the density of the amount that we're able to run on each instance, right? So one problem with just loading up instances with disparate type of workloads is state management. If you have 3 different web applications, now you have 3 different sets of dependencies, binaries, libraries, kind of commingled on the server. Maybe you have version conflicts where one application requires version 1.0 of some library and one requires 2.2. Now you can't run those concurrently. Containerization really, really, really helps here, right? So a container, a Docker container, is a shippable artifact that includes not only your application, but its dependencies. And the EC2 container service allows you to very easily deploy Docker containers onto AWS without managing your own orchestration software. So let's say you have those 2 applications, the one that requires version 1.0 of something and another version that requires 2.2. You can create 2 different Docker containers. You have 2 different Docker files that build those dependencies, package them into a Docker container, and they can coexist on the same EC2 instance. So here we have, we're able to reduce our spend, so this is the important bit, from 5 instances to 3, and those 3 instances are much better utilized, right? And we still have our 5 containers running, and maybe this has one set of dependencies, this has another, this has another. But now we could bin pack the work that we're doing onto a smaller number of instances and spend less money, right? A lot of benefits here. Yes?
Can we do that across accounts?
Across accounts.
I manage a few of my clients' AWS accounts. So can I do that across AWS accounts?
Yeah, absolutely. So I mean, you can have a separate 2 clusters across accounts, right? That's generally how customers do it. Could be the same applications, right? But just running within different EC2 contexts. We're going to talk a little bit more about kind of containers and how that fits in. But we see a lot of pickup with containers because it just makes it a lot easier for customers to get predictability in their development cycle. It makes operations a lot easier. It solves a whole class of problems. The enemy when dealing with managing instances in the cloud is state, right? So if you have some state where you need to, before this application can run, you have to run this script, and this script installs version 2.2 of that library, that is a liability. That's a pointed gun right at your foot waiting to go off. Using a Docker container lets you encapsulate that state into a shippable artifact. We'll talk a little bit more about state. The EC2 container service, so has anyone heard of like Kubernetes or ECS? Okay, cool. So there are different ways to run Docker containers. The trick with running a Docker container, it's easy to run one container, right? And Docker run, maybe -d, make it a daemon. That's all well and good. You could do that very easily. problem is if you're doing a microservices-based architecture, it's not just one Docker container you're running. You're probably running many Docker containers, many different Docker containers, Docker container images. And you need something to orchestrate that. What happens when that Docker container dies? Like, let's say I introduce a bug and someone hits an endpoint and that Docker container crashes. Whose job is it to restart that Docker container? What if an instance disappears? Maybe AWS has a service event and an entire availability zone goes down, right? Can happen. How does that Docker container get restarted within another availability zone? This is the province of EC2 Container Service. This is the problem it solves for you. It is a way to easily manage clusters of any scale. It could be 2 servers, could be thousands of servers. You can dictate what containers get placed on what instances. Maybe you have a container that requires GPU access. Maybe you have another container that requires high amounts of memory. You can configure that all within the EC2 Container Service. It's extensible. It performs at scale. We build on it a ton. You know, someone mentioned before AWS Batch was built on ECS. Things like CodeBuild. Like there are tons of AWS in general is using EC2 at scale, ECS at scale, as are many of our customers. Let's talk about development environments. Development environments are a great opportunity for cost savings. How do you bank some free money here? So your developers generally will work a certain number of days in a week and a certain number of hours on those days. So there's built-in idle time. So instead of running your development environments 24 hours, if you get into a state where you can power on and power off, that's a much better place to be. So here you're banking 8 hours. That's like right back in your wallet, and you're ensuring that the system is up during business hours. So you can use EC2 Scheduler for this. If you Google EC2 Scheduler, you'll find an AWS Answers page, and very quickly, EC2 Scheduler is just a Lambda function, right? So one of the cool things about Lambda is that you can use it to automate your infrastructure. So you can use Lambda to start and stop instances on a schedule. You can say, at 8 a.m., let's make sure my development environment is up so that my developers can come in and they can get to work. And when they go home for the day at 9 p.m. or 8 p.m. or whatever it is, 5 p.m., shut down all that infrastructure, right? Why pay to run it all night? No one's working all night, hopefully. Hopefully you're not in that place. That's another talk. But take advantage of stuff like this. Like there's no reason to run these instances all the time. You're just pouring money down the drain. And here's a little bit more about EC2 Scheduler. Words. So you can point EC2 Scheduler at a certain set of resource tags. So maybe you have a tag like environment:dev. You could say, none of my dev environments need to be running on the weekend. I want them all stopped on Friday night, right? That's very easy to do. You can get that done within 15 minutes by installing EC2 Scheduler. Super worthwhile. Next, autoscaling. So we touched on this before. So autoscaling, you can scale by metrics, right? And that's like if CPU goes above 80% on my autoscaling group, then I want to add instances. Or if it goes below 20%, I want to remove instances. Totally, you can do that. It makes a lot of sense. For some workloads, scheduling might make more sense. Like maybe you're a B2B application, and you know that work comes in to your application 9 to 5, like clockwork, right? You know this because you have metrics, and you look at the metrics and you see the graph. You can tell EC2, scale up in the morning. Let's create 6 instances and keep those running. If you need more than that, use this metric to scale up, but make sure you maintain 6. And at night at 6 p.m., scale them back down. Let's have up 2 just for those stragglers who may be working around the clock, those poor souls. You could scale, so you can scale by policy, scale by schedule. Super powerful. I mean, there's so many classes of application where maybe you're US focused, maybe you're East Coast focused, where there's just no reason to maintain the same fleet size during the night. So use these tools. Make sure you're not paying AWS $1 more than you need to. And then finally, you want to, the tug on cost optimization, especially with dev workloads, is always efficiency, right? You want to make sure that you're spending the least amount of money possible, but no less, right? It's like a Dieter Ram quote, like good design is removing everything, but nothing more. You want to make sure that your developers don't hit a wall where they're like, I couldn't get this work done because you're trying to pinch pennies and my development environment isn't there. The best thing you can do is give your team tools so that they can spin up and spin down their own instances. So chat ops is a great way to do this. Something I've done in the past is I worked at a company where we had 10 developer environments, red, green, blue, whatever. And we were turning them off at night, but it was still inefficient because we weren't using all 10 at any given time. And they were just long running. They were just, they just existed. And instead of doing that, instead of keeping them running, what we did instead was we created an interface through and exposed it through chat ops, where any engineer can say, I have a topic branch on GitHub. I want to take that topic branch and spin up a new environment. So with one command, like new environment, new, and then topic name, the chat ops bot would go, provision the infrastructure necessary using a CloudFormation template, tag it so that it knows, so that AWS is aware of the fact that this is being spun up by this user for this project, with this cost center code or whatever. All done for you. So the customer doesn't have to, the engineer himself, him or herself, do not need to worry about spinning up infrastructure to work. They can just run one command and they'll have a standard cookie cutter environment. Even better, now that environment is tracked. So you can have like a Lambda function or something that looks at those environments and figures out which ones aren't used anymore and reaps them. Maybe you have like a 7-day limit. At the end of 7 days, it just kills it and then tells your dev group, hey, I killed dev environment new login page because it's 7 days. Or maybe it says, new login page hasn't had a deployment in 2 days. I'm going to kill it. Yes, no. So it increases visibility. It creates an interface for your team to be able to spin up infrastructure in an improved way, in a tracked way. Here we're demoing, this is Mackenzie demoing, you can have a chat ops box that lets you power on and power off instances. Again, like this lets your developers, without having like console access to EC2, have an interface to be able to move, create the resources they need to get their work done with team awareness. Everyone sees that this happened, that this is powered on and powered off, and then folks can, it creates an environment where people are more conscientious about what they're using, what they're spending. Sizing is really important with dev instances. This is the easy one. We see lots of dev instances that are like M4 larges. And it's like, don't spend tens of dollars a month on those development instances. Spend dollars, right? Make sure you're right sizing your workload all the way down. And be aggressive here. Because again, like a T2 Nano or a T2 Micro, you could pay like a penny and a fifth for your dev instances as opposed to paying a couple bucks an hour. Deploy pipelines, so seeing cost optimization is more about, it's more than just like the monthly run rate of your infrastructure that you pay AWS. Right? There's cost in your development process. As I mentioned, you don't want to slow down your developers to pinch pennies, right? Because it's penny wise, pound foolish. If you put a bunch of resource limitations in the way and you're saving $100 a month, that's awesome, but your developer, who maybe you're paying hundreds of dollars a day, is now blocked. And he or she can't do their job, and that's a loss, right? That's a net loss. So keeping your development environment, keeping your developers unblocked, keeping your process fast, keeping all of this automation in place is important for that. Development pipelines or build pipelines, CI/CD pipelines, help you. It's an automated manifestation of the process that you take to get your code from your source code repository into production, right? So from your source code layer all the way up to monitoring in production. Part of that is building your code, right? So maybe that actually means like you're using like Java or Go or something, and you're compiling some sort of binary or artifact. Maybe you're running unit tests, right? Maybe you're using Node or Ruby on Rails, and you're running RSpec specs or something like that. But there's a build step, right? So you have a CI server. It's running tests against your build. It's compiling your build. And there's a red light, green light. If your build's broken, your team's made aware of it. This is always an opportunity. If you're running your own server to do your own builds, there's always a cheaper way to do that. So the retrograde example is that you're running like a Jenkins server and it's running 24/7. There are so many ways to optimize that. So one cool way is with Jenkins in particular. Jenkins is just a CI server, it's open source, very popular. You can use its Spot Fleet integration plugin to plug Jenkins into Spot. So instead of using on-demand instances and paying by the second, premium price, you could tell Jenkins, actually build using this type of instance, and I'm willing to pay this much. Right? And that's your bid, and you'll be charged the marketplace price. So a super, super easy way to like lower your bill right away. Like instead of paying top dollar for build servers, use Spot. Right? And Jenkins makes it easy. You install a plugin, you tell it what you want to pay, done. There are alternatives to that. We launched at reInvent last year a service called AWS CodeBuild. So CodeBuild is a build service. The idea here is that you're not managing servers of any kind. You are basically, you give CodeBuild your project, your source code repository, and it will build for you. It'll spin up all the resources you need. It'll do your build, and it'll let you know if it passed or failed. The really cool bit about CodeBuild, so there's per minute billing, not per second yet, but it's per minute. So you're not paying for on-demand instances. But the really cool thing is, like, I've always been on that dev team where you check something in, you have a topic branch, you want to be done, and you have to wait, right? The build process is blocked. There are 3 builds going, there's no more slots for you, you just got to wait. So you go play ping pong or whatever it is. CodeBuild, you get instant scale. So you don't have 3 slots, it'll just scale as much as you need to as many builds as you need to run concurrently. It sounds like a small thing, but it's so important to keeping your developers moving and unblocked. CodeBuild's a really cool service. I would encourage you to check it out. Let's talk more about state. So how am I doing on time, Brent? Pretty close. All right. Well, 5 minutes? Sure. All right. Let's power through this. Let's skip this slide. So I talked about state. So state is often the enemy when it comes to operating instances in production, right? You don't want your instances to be, it's the old pets not cattle analogy. You don't want your instances to be these things that you name, that you take care of, that you kind of craft by hand artisanally. You want them to be disposable, right? So here's a common situation where you have a service failure. Someone logs into that box, they manually make a tweak, and the service recovers and everyone's psyched, right? That was in February. In April, you have 3 new developers. They provisioned a new instance. They're missing the manual tweaks because no one documented it. It wasn't done through infrastructure as code. The service fails. The problem here isn't the missing manual tweak. It's the fact that tweaks are made manually. So getting to a state where, like blue-green deployment, where every new deployment you launch new instances helps you sort of keep these servers pure. You always know the state of them because anytime a state change happens, it's a new server. There's no question about state there. All right, so very quickly, I just want to touch upon this before we get out of here. So serverless. The idea of serverless here, you look at the evolution. So let's say 2006 with EC2, you could provision servers in minutes without requisitioning hardware, right? Huge advance. But your concern space was still quite large, right? You have to worry about the OS, you have to worry about security patches, you have to worry about the applications. Docker and specifically, but containerization in general, helps reduce that a little bit. When you deploy a container, you're less worried about the underlying instance. In fact, you want that instance to be as skinny as possible, and you're more focused on the environment and the dependencies of your application. Serverless is the extension of this, where you're not worried about any of that. You're worried about your code that your business needs to run for your customers. So, a typical example here is an API call through API gateway, goes to Lambda, goes to DynamoDB, and this could be a microservice representing an operation against a piece of data. So we're done. In summary, Brent, pay us as little as possible, but no less, right? And press on your AWS account team to help you pay less. It's something that's important to. I can't stress enough that this is part of our focus. We want you to pay as little as possible. Ensure that you're aware of your application's behavior. Increase your visibility into your application. Find opportunities for cost reduction, idle servers, build servers, development environments, and be aggressive. Be relentless about stamping cost out of your infrastructure. These slides will be online. There's a bunch of stuff here about helping you, right sizing, which is the EC2 scheduler is linked from there as well. And that's that. Thank you all for your attention. Super appreciate it. Thank you.
Thanks, guys.